Ladies and gentlemen, we're going to go ahead and get started. In the name of the Father and of the Son. Oh, gotcha. See, that always works. Let's close the back door. Thank you. Good Catholics. Okay, we're going to continue our conversation today. This is, again, the Intro to Crypto track. My name is Jim Friend. I'm your moderator for this track, and just so pleased to be with you all today. We had some great discussion. Unfortunately, we ran a little bit late, so we cut it just a little bit short, but I know that Deacon Rich will be around for those who didn't get a chance to talk with him. We have another wonderful speaker here for this workshop, Xavier Decyper. He's a widely followed YouTube creator on technology. He's a native of Belgium. In fact, he just came over from Belgium today. His channel, Simply Explained, has more than 430,000 followers, and his videos have more than 28 million views. And I watched a couple of them the other day, just fantastic videos. If I can understand it, Xavier, I know that anybody can, so thank you. Making him one of the most recognizable technology commentators in the world. His Simply Explained YouTube channel focuses on making the complex simple, putting technology topics in plain, simple terms that all can understand. Xavier received his bachelor's degree in computer science from the Hoge School Gent. He works full-time as a full-stack developer at a large bank in Belgium, which gives him a unique perspective as he lives daily in both traditional banking and the new world of internet finance. And on the topic of intro to cryptocurrency, please welcome Xavier Decyper.
All right, good morning, everyone. That was an awesome introduction. Thank you very much for that. Okay, so that makes these slides a bit redundant, but yeah, hello again. My name is Xavier. Like the introduction said, I am the creator of the YouTube channel Simply Explained, and I have a passion for taking complicated topics and explaining them in a straightforward way. And that is exactly what I do on my YouTube channel. I take topics related to technology, and I make simple explainer videos about them. And so I have videos about blockchains, NFTs, cryptocurrencies, but also about things like caching, NoSQL databases. And I even have a video about SpaceX and what software they use to design, launch, and land their rockets. So, what am I going to talk about today? I'm going to talk about cryptocurrencies, but first we're going to talk about currencies themselves and see how both differ from each other. I'm going to talk about the underlying technology that makes cryptocurrencies possible, which is blockchain. I know the talk before me also gave an introduction, so I will try to go through it very quickly. We're going to talk about exchanges and private keys and wallets, what those things are, how you can make them, and why they are relevant. And I'm going to address the downsides and the challenges that cryptocurrencies face going forward. At the end of the talk, I will also foresee some time for questions and answers. So I hope to be speaking for about 35 to 40 minutes on the first few topics, and then there's going to be hopefully 10 to 15 minutes time left for questions. All right, let's get going. Let's start with the basic question. What is a cryptocurrency? Before I answer that, let's first take a look at what is a currency. Now, I'm a bit lazy, I'm a millennial, so I took a definition of Wikipedia, and Wikipedia said that a currency is a standardization of money in any form in use as a medium of exchange. And there are two important keywords in this definition. That is a standardization and medium of exchange. Now let me tell you why that is important. Let's take a look at how money came to be. Let's imagine that you're a farmer and that money didn't exist. And let's imagine that you, the farmer, you want to buy a new tractor. But the only thing you can offer the dealer of that tractor is your produce. So you can go to the dealer and you can say, hey, do you want some wheat or some corn or whatever? But what happens if the dealer says, well, I already have all the food that I need. I don't need any more. I'm not going to trade you a tractor for your food. Now you have a problem. Well, a currency and money solves this problem because now you as the farmer, you can sell your produce to anyone who needs it and you can get money for it in return. And then you can take that money, you can go back to the tractor dealership and you can exchange your money for a tractor. So a currency acts as a common denominator. In this case, the farmer is willing to sell his produce for money because he knows he can then use that money later on to buy a tractor. Whether that's a Tesla tractor or not, that's irrelevant here. And it's the same thing for us. We are all willing to work for money because we know at the end of the day we can use that money to buy things like food or pay the rent or invest in cryptocurrencies. Now, why do we trust money? Why do we trust a currency that inherently has no value? Well, we trust them because they're being issued by big central authorities, such as, for example, a central bank. And we trust them because everyone else trusts them, right? I'm willing to work for money because someone else will accept my money to buy something different. We all have trust in this authority. Now, there are downsides to this. Mainly that we do have to trust these entities. We have to trust the government and a central bank. We have to trust our own banks who keep our money. And these two don't always have our best interests in mind. A government and a central bank, for example, they can print more money, which causes inflation, something that we're seeing today. A bank, on the other hand, they can deny your transactions. They can say, well, you're not allowed to send your money to a cryptocurrency exchange because we don't want you to. And they can block withdrawals. If you want to take out all of your savings in one go, the bank could say, well, we really don't want you to do that. Let's do that in stages. So the question is there a better way? And the answer is obviously yes, with a cryptocurrency. Now, how does a cryptocurrency differ from a regular currency? Well, first up, a cryptocurrency is completely digital. That means it doesn't exist in a physical form. There are no banknotes, there are no coins. It only exists in the memory of computers. And the second big difference is that instead of relying on central authorities, cryptocurrencies don't do that. Instead, they are completely decentralized. They are peer-to-peer. Now, I said that money is all about trust, but if you're decentralized and you don't have any central authorities, how can you trust the people in this decentralized network? When it comes to money, people do all kinds of strange things just to get more money. They try to game each other, try to fool each other. So how do you trust people? For example, there's this thing that we call a double spending attack, where an attacker, here on the left, imagine that he only has one Bitcoin. And he tries to send that Bitcoin to person A, and straight after, he sends that same Bitcoin to person B. How does that second person know that he already spent that Bitcoin if there's no central authority, if there's no bank that keeps track of the balance of our attacker? How does that work? Well, it turns out that this is a very hard problem to solve. In fact, it wasn't fully solved until Satoshi Nakamoto came around and he gave us Bitcoin. My clicker is not working. So he proposed Bitcoin as a solution, a digital, electronic, peer-to-peer cash system. And the major innovation that made this all possible was the blockchain. So, what is a blockchain? Once again, Wikipedia to the rescue. A blockchain is an open distributed ledger that can record transactions between two parties in a verifiable and a permanent way. There's two keywords here that I want to highlight. That is a distributed ledger and permanent transactions. Let's look at both of those, and let's start with permanent transactions. When it comes to money, the actions we take are indeed permanent. If I send you $100, then I can never get my $100 back. They now belong to you. The only way in which I can get them back is if you do an opposite transaction, if you send me those $100 back. I cannot go in and change that first transaction. It's happened. It is set in stone. So we're saying that blockchains are immutable. You can create new transactions, but you can never change transactions that have happened in the past. And the second keyword is a distributed ledger. What does that mean? Well, this overview of transactions, it just means that everyone who wants to participate in this decentralized network gets a full copy of all the transactions that happened. Everyone can see who spent their money and how they spend it. In fact, the people in this network, they create consensus amongst each other. In the case of a cryptocurrency, they agree on how people have spent their funds and how much everyone still has left. Now, if this blows your mind, that's okay. Let's take a look at the underlying technology that makes this all possible. Let's take a look at blockchains and how they work behind the scenes. A blockchain is basically just a chain of blocks. It's in the name. But what is a block? Well, a block is basically a container for data. It's like a file in your computer that once you open it contains a lot more stuff. Well, what stuff does it contain? Well, each block on every blockchain contains three things. It contains some data, it contains a hash, and it contains the hash of the previous block. Let's go over each three of those. Some data. In the case of a cryptocurrency, blocks contain transactional data. In this case, I send someone $100 or 100 Bitcoin, whatever. But you can use blockchains for other things. You could, for example, store important documents in there. Contracts, patents, your will, for example. Documents that need to be time-stamped. Anything can be stored in the blockchain. Doesn't have to be transactions. The second thing that each block has is a hash. And this is a very technical term, but a hash is basically like a unique fingerprint of that block. And you get it by taking all of the data in the block, you run it through a hash function, and then the output is that gibberish that you see over there. It's a randomly appearing string of letters and numbers. But what is important is that if you change something inside that block, the hash of the block changes completely. So if there's a transaction in that block that says that I received 1 Bitcoin and I change it to 2 Bitcoin, then the hash will be completely different, even though it's just a small change. And the third thing that all blocks contain is the hash of the previous block. And this effectively creates the chain of blocks. So this hash thing might be a bit confusing. So let's take a look at a sample blockchain. Here's a blockchain of 3 blocks. Block number 1 has a unique hash. In this case, it's 1Z8F. And it's the first block on the chain, so it doesn't have the hash of the previous block, right? I just set that to 0. Now, the second block also has a unique fingerprint. In this case, it's 6BQ1. But this time, it refers to block number 1 as the block that went before it. So block number 2 says, hey, the hash of the block that went before me is 1Z8F. And that checks out. Same thing for block number 3. It has a unique hash, and it points towards block number 2 as the block that went before it. Now, why is this important? Well, let's imagine that someone tries to change something inside this blockchain. Again, there's a hacker who says, well, block number 2 contains a transaction. It says that I received 1 Bitcoin. Let's change it to 1,000 Bitcoin. So he makes that change, and as soon as he does that, the fingerprint of that block, the hash of that block changes. Now it's H62Y. And now block number 3 has a problem. When we validate the chain, block number 3 will say, yeah, but wait a minute. The hash of the block that went before me should be 6BQ1, but it's something completely different now. What is going on here? So nothing prevents you from changing data inside the blockchain, but as soon as you do, you can notice. You can see that someone has tampered with that data. Now, I hear you thinking, okay, if I'm the attacker, I just move along to block number 3 and I mess around with that until the hashes match up, right? I just link up block number 3 with block number 2. What's preventing me from doing that? Well, there are 2 security mechanisms that make sure that that cannot happen. That is a consensus algorithm and the peer-to-peer network. You might have heard about proof of work and proof of stake. So let's look at that consensus algorithm. A consensus algorithm basically slows down the creation of blocks. In the case of Bitcoin, you can only create a block every 10 minutes. You cannot do it faster than those 10 minutes. How does it work? Well, it's basically a cryptographic puzzle. You need to do a lot of intensive calculations to be able to solve this puzzle, and those take, on average, around 10 minutes. We call this process mining in case of proof of work. So in this case here, I have a blockchain of 2 blocks. After block number 2 has been added, it will take 10 minutes for the 3rd block to be added. 10 minutes after that, we'll have a 4th block, and so forth. Now, this impacts an attacker as well. If an attacker changes something inside block number 2, he has to rework that cryptographic proof. He has to rework that puzzle, and that will take him at least 10 minutes if he has really powerful computer hardware. It might take him a lot longer. And then he moves on to block number 3 to make the chain valid again, and that one will take him, again, 10 minutes. Take 10 minutes to completely rework that puzzle. But by that time, the network, the rest of the people, will have already added a 4th block to the chain. And so the idea is that an attacker can never catch up. He is always running at least 1 block behind. And the second thing that secures blockchains is, of course, that peer-to-peer network. Those people that are creating consensus amongst each other. Everyone is constantly validating the records that they have. And as soon as they see that someone comes around and tries to change what already happened, they will just ignore him and say, you're not part of our network because you're not playing by our rules. So, to summarize what a blockchain is, it's completely distributed. There's no middleman. Everyone can transact from one person to the other. It's open for everyone. If you have a computer and you have an internet connection, you can join this network and become a part of it. And blockchains are completely immutable, which again means you can only add new transactions to it or new data to it. You can never change something that was already created. How does this relate to cryptocurrencies? Well, cryptocurrencies are built on top of blockchains. In fact, you could say that they are an application or a use case of blockchain technology. And I mentioned before, you can use blockchains for other things. For example, as a notary to timestamp documents or to keep track of your will or contracts or patents. Cryptocurrencies are just like that. They're an application of blockchain. So that is how blockchains work in a nutshell. But remember, we were talking about cryptocurrencies. To summarize that, cryptocurrencies are just a form of currency, just like euros and dollars, except in this case, they're completely digital. They work without any intermediaries. There's no banks, no central banks, no governments. It's just the people. And it's peer-to-peer. Everyone is equal. Anyone can join this network. There are no requirements. There are no restrictions. Now, at this point, you might have 2 questions, or maybe more, but we'll get to that later. You might think, well, how do I get crypto? And if I get it, where is it then stored? If it's not physical, where is it? Let's start with the first one. How can I get crypto? There's really only 3 ways in which you can get crypto. Someone can give you some crypto, a friend, for example. You can mine it, or you can buy it through an exchange. Let's look at mining. What does it mean to mine for cryptocurrencies? Well, mining just means that you join this peer-to-peer network. You let your computer participate in it, and you help achieve consensus amongst people. As soon as you join this network, you will get a full copy of the blockchain, and you will start validating transactions. And for your work, for all your trouble, you will receive a mining reward. That's one way you can get cryptocurrencies. But there's a bit of downside to this in the sense that you need very powerful computer hardware, so that's not for everyone. So the best way to get cryptocurrencies is to go through an exchange. What does an exchange do? Well, for example, Coinbase and Binance, they allow you to take your dollars, send them to them, and then you can buy, sell, and trade cryptocurrency assets. And as soon as you bought them on an exchange, they will also keep them for you. They will store them for you. So that answers the second question as well. Where is my cryptocurrency stored? Well, if you buy it through an exchange, it's the exchange that stores it for you. But wait a minute. I just said that cryptocurrencies are supposed to be decentralized, that there are no middlemen. And now I'm telling you that exchanges store your coins? That doesn't make a whole lot of sense. And it doesn't. These cryptocurrency exchanges, they're not perfect. In fact, just last week, we saw one go bankrupt because they mismanaged user funds. And it happened in the past as well. Even Binance, for example, they got hacked for $500 million. So the answer is obviously don't keep your crypto in an exchange. Simple as that. But that still doesn't answer the question. If I can't keep them in an exchange, where do I keep them? Where do I store them? Well, let's talk about wallets and private keys. A wallet is a way to store your coins so they are 100% under your control. There's no one else who is managing them. All right. What is a wallet and how do you create a wallet? Here's where it becomes a little bit technical. A wallet is basically a key pair that was being generated with a specific algorithm. In the case of Bitcoin, it's through an elliptical curve digital signature algorithm, but those are just details. The thing you have to understand is that this algorithm will spit out two keys, a public key and a private key. And these keys are mathematically linked to one another. You can take your private key and you can derive the public key from it. But you cannot do the opposite. You cannot take your public key and derive the private key from it. So what do both keys do? Well, the public key functions as your wallet address. As the name suggests, it is public. It can be shared with anyone. It's like your bank account number. You can give out your bank account number to anyone. The only thing they can do with it is send you money. Now, the private key, on the other hand, proves that you are the owner of a wallet. It allows you to cryptographically sign transactions and spend the money inside your wallet. And, you know, the name is private key. This one should be kept private, because if you share it with someone else, they will be able to spend the coins in your wallet. Now, what's interesting is that you can generate an unlimited amount of key pairs offline on your own computer, and all of those will be valid wallets. All of those can be used to receive money. Now, that's weird. Well, it's because blockchains don't keep a list of all the known wallets. If you go to your bank and you open a bank account, the bank obviously knows that that account is in existence, that it's existed, right? They store it in their database. A blockchain doesn't do that. A blockchain only stores transactions. It doesn't know if the to address of a transaction actually exists. And it doesn't care. The only thing it cares about is that a transaction is correctly signed by the owner of the from wallet, right? In fact, blockchains don't even store the balance of wallets. They only store the transactions. If you want to know the balance of a specific wallet, you just look at all the transactions where that wallet was involved, and then you just sum up the amounts, and you know how much money is in that wallet. So that's really interesting, because now it means that I could generate a key pair on my computer while being offline. I could then send my public key to a friend. I can print it off on a piece of paper, for example, and give it to him. And my friend can then send crypto to my wallet, all without me ever being online, all without the blockchain ever having seen my wallet before. So, that works because blockchains only store transactions. They don't care about the receiving wallet address. It can be anything. You can send money to any wallet that you want. The only thing that a blockchain cares about is that transactions should be signed with the private key of the correct wallet. If I want to spend coins from my wallet, I have to sign it with my private key only. I cannot sign it with another. Now, this private key is a really big deal. If it allows me to spend my money, where should I store it? How should I keep it safe? There's a couple of options. For example, you could use a paper wallet. You can generate a public and a private key on your computer, and then you can print it out. It looks something like this. There's two QR codes on this piece of paper. There's a QR code that represents the public key and one that represents the private key. Right? Very secure way. You could buy cryptocurrencies on an exchange, generate a wallet, print this out, and then ask the exchange to transfer your coins to your paper wallet. And then it only exists on a piece of paper. And nobody can hack into that. Nobody can, and nobody can hack into it, but you can also not share it by accident on Dropbox, for example. Another way to store your private keys is through a hardware wallet. That's a little device that looks something like this that can generate these key pairs automatically on the device itself, and it makes it so that you cannot extract your private key from it. So a hacker cannot hack these devices and get your private key and then send away all your money. So managing your own keys and your own wallets is essential if you want to have full control over your cryptocurrency assets. And it ensures that there are no intermediaries. As soon as your funds arrive in your own wallet, you're in control. But that also means that it's your responsibility. If you lose your private key, you lose the ability to spend your funds. Your cryptocurrency will still be there. It will still sit in your wallet. The blockchain still has all the transactions, but you will not be able to spend it because you've lost your private key. In fact, we read these news stories every now and then about people who forget the password for their private key, for example, and now their Bitcoin is suddenly worth millions. Or there's people who generated a private key and they put it on a USB thumb drive or on their hard drive or whatever, and they accidentally threw it away, and now they're looking in a landfill to try and recover it. All right, now you might have even more questions. In fact, these are the top 2 questions that I get as a reaction to my videos, and that is there only one blockchain? And why are there so many cryptocurrencies? Why not just a handful, like real currencies, like the dollar, for example? Well, let's look at the first one. Is there only one blockchain? I sometimes hear people talk about the blockchain. Well, there is no the blockchain. There are many blockchains out there. So the answer is no. But it's a little bit more complicated than that. So the biggest cryptocurrency projects, they all have their own blockchain and their own consensus algorithm. But some cryptocurrencies are built on top of others, and we call those tokens. You might have heard about that as well. So here are 6 of the most popular tokens at this moment. Dogecoin is one of them. Tether is also one of them. They don't have their own blockchains. They rely on the blockchain of another project. In this case, I believe all of these are actually built on top of Ethereum. So they're built on top of another blockchain by using smart contracts. And I will explain smart contracts actually in my talk later this afternoon. So if you want to attend that one, that would be great. We call these ERC20 tokens. You might have heard about that as well. They live on the Ethereum blockchain. And ERC20 is just to say that it's a smart contract with a specific format. And that smart contract is keeping track of how many tokens there are, all the transactions of that token, and it allows people to exchange Ether, for example, into that particular token. Now, the second most asked question that I receive is, why are there so many cryptocurrencies? I checked on CoinGecko last week, and they mentioned, or they're tracking currently, 13,000 different cryptocurrencies. That's a lot of cryptocurrencies. How should you know in which one you have to invest? Well, there's a couple of reasons why there are so many. For one, it is very easy to create your own cryptocurrency. You can just go to a website, fill out a form, give your cryptocurrency a name, define how many coins there should be, click a button, and boom, you have your own cryptocurrency. So a large part of those are probably just tryouts, people experimenting and making their own currencies. Cryptocurrencies also might have different needs and goals. For example, we have something called stable coins, like Tether. And the purpose of stable coins is to tie their value to something else. For example, Tether, as soon as they make a new coin, they take $1 and they put it in a bank account as a reserve. And so as a result, 1 Tether is always equal to $1. The value is always fixed at $1. And you cannot do that with a general purpose currency like Bitcoin, for example. You need to create your own cryptocurrency project. And finally, some of these are born because of disagreements. We saw that, for example, with Bitcoin a couple of years ago, when there was a group of people that said, you know, we need to make Bitcoin more efficient, so we're going to change the way we store transactions so that we can store more of them inside a single block. And other people said, yeah, but why don't we just make the blocks bigger? That's also a good idea. Both groups couldn't agree, and so the result was Bitcoin was forked. A group of people continued working on Bitcoin as we know it today, and the other group started working on Bitcoin Cash, which you might have heard of. So why are there so many? Well, it comes down to different people having different ideas and goals. And because it is so easy to create, they just try. They make their own project, they make their own cryptocurrency, and they see if it sticks. Now, some of those also are just scams. There's no way around that. It's very easy to create. A lot of these projects are just people promising a lot, saying that they have amazing technology, They're asking you to buy their coins, and then as soon as they have enough, as soon as they sold enough coins, they take your money and they disappear. So some of these are definitely also just scams. All right, now, I hope that at this point you're thinking, wow, this is amazing. Where can I sign up and invest all of my money? To that I would say, hold on. I talked a lot about the upsides of cryptocurrencies, but there are also downsides. So let's address some of those. I will address 4 downsides to cryptocurrencies, but there are more. For starters, scalability. You know, a payment network like Visa, for example, they have the capacity to handle 65,000 transactions per second. They're not actually doing that many transactions per second, but that's what they're capable of. How do cryptocurrencies compare? Well, Bitcoin can do 7 transactions per second. Oh, and Ethereum does a lot better. They can do 20. So they're not that scalable at the moment. These are just the 2 biggest, by the way. Now, there are solutions for this. For example, sharding. This is something that Ethereum is looking into, where you take your very big blockchain that is very slow, and you split it into many smaller parts. And each time you split it, you double the amount of transactions per second you can handle. That's a possible solution, but it needs to be implemented. And so until we have something like this, we remain at 7 or 20 transactions per second. Another downside is speed. How fast transactions can be completed. I looked at the average time that it took for a transaction to finally settle, and for Bitcoin this year, that was 40 minutes. For Ethereum, 14 minutes. That's a long time. So just imagine submitting a transaction to your bank, and it takes 40 minutes just for your bank to acknowledge that they've received that transaction. And these numbers fluctuate as well. If there's a lot of people transferring Bitcoin or Ethereum, then those waiting times, they go up. They go up massively. Once again, there are solutions for this. They're just not implemented. Sharding can help with this as well. We also have something that we call layer 2 solutions, whereby you're going to try to take certain transactions and prevent them from being written into the blockchain. In Bitcoin, for example, they're proposing the Lightning Network. Third downside is energy usage. I looked up this graph that calculated how much energy the Bitcoin network uses on a yearly basis. And it's a little small, but it says that Bitcoin uses 100 terawatt hours of electricity every year to power all their miners, all the people that are participating in this network. So how much is 100 terawatt hours of electricity? Well, if you compare it to countries, then Bitcoin uses more power than the country of Finland or Belgium. Now, I'm from Belgium. 11 million people live in Belgium. And Bitcoin alone uses more electricity than 11 million people, plus all of our businesses and our industry and stuff like that. So it uses an enormous amount of electricity. Now, once again, there are solutions for this. They just need to be implemented. You can transition away from proof of work to something like proof of stake or proof of space. In fact, Ethereum has done that just this year. They migrated to proof of stake, and they are now using 99.99% less power. So Ethereum is now pretty green. They're just not that fast yet, so they have to keep working. The final downside that I want to talk about is user experience. I talked about how important it is to manage your own wallet and your own private key. And here's a website where you can generate your own key pair. Doesn't look pretty. There's a lot of buttons on here. There's a lot of text. All of a sudden, it spits out 2 QR codes and a bunch of random characters. How am I supposed to know what this is, how I can use it? And then if I have my private key here with my QR code, how do I use that to spend my funds? It's not that easy. There's a lot of jargon involved. There's also no customer support. If you cannot do this yourself, you have to rely on the community. You have to go on Facebook or on Reddit and ask people, hey, how do I do that? Then you have to trust that those people will actually help you and not just steal your money. And then there's also a lot of questions if you get started. Where do I store my keys? Hardware wallet, paper wallet, on my computer, encrypted drive? how do I do that? What exchanges are good? Which are safe? Which are not that safe? What is cold storage? What is hot storage? What are gas fees? Just, these things are not easy to use. So, these are just 4 limitations that, in my opinion, need to be overcome before we can see cryptocurrency go for mainstream adoption. And as I mentioned, there are more downsides as well. For example, price volatility. The price or the value of Bitcoin, for example, constantly fluctuates. That makes it hard for a business to accept Bitcoin or any other cryptocurrency as a means of payment, for instance. There's lots of scam projects. There's no customer support, and so forth. So, I believe that cryptocurrencies have a very bright future, but that they still have a long road ahead of them before they can actually reach mainstream adoption. So, my timer says 40 minutes, so let's summarize this talk. We started by talking about currencies. What is money and what is a cryptocurrency, and how do both differ from each other? I talked about blockchain, the underlying technology that make cryptocurrencies possible. We talked about exchanges, private keys, tokens, wallets, why those are important, why you should use them, and how they work. And finally, I addressed some of the downsides and the challenges that the cryptocurrency space has and that they need to solve for mainstream adoption. Now, I mentioned it already. If you're interested in DeFi, I will give a talk later this afternoon at 3 p.m. in this same room. Please attend it as well. I think it's pretty interesting. And then lastly, I just want to shout out my socials. If you want to learn more about this stuff, about cryptocurrencies, about blockchain, smart contracts, that sort of thing, then definitely follow me on YouTube. My channel is called Simply Explained. I'm also on Twitter, where I occasionally share my thoughts. And if you want your curiosity tickled, then you can sign up for my monthly newsletter, where I share cool things that I found on the internet related to science and technology. And with that, I want to thank you for coming to this talk. Thank you for paying attention. And I propose that we use the remainder of our time for questions. Thank you. Yes?
You explained before that Ethereum has changed from proof of work to proof of space. Can you elaborate on that a little bit?
Yeah. So the question is, Ethereum transitioned from proof of work to proof of stake, and if I can give some more details. That was a really long process. It took Ethereum, I think, 3 or 4 years to actually finalize that transition, and they actually did it in stages. There was a point where they actually copied the Ethereum blockchain, and they ran a separate version of that with proof of stake to verify that everything was working correctly. But so in a nutshell, proof of work is all about that cryptographic puzzle. It is about doing a lot of mathematically intensive computations to solve that puzzle, and that is worth something, right? The electricity that you burn for that. With proof of stake, it's different. You basically lock up an amount of ether into the network, and that's basically a guarantee. For example, you deposit, let's say, 100 ether into that network, and then you start validating transactions. So you're basically looking, okay, this person wants to send money to that person. Does he have enough funds to do that? Was the transaction correctly signed, and so forth? And if it all checks out, you stamp it and you say this is valid. And the idea behind proof of stake is that you're incentivized to play by the rules, because if you validate a fraudulent transaction, your stake will be taken away. And so if your stake is big enough, you have more to lose than to gain by cheating the system. That is basically the difference between proof of work and proof of stake. And that's also why proof of stake is so less energy efficient, because all you have to do is just look at signatures and look at balances if people have enough money. Does that answer your question? Okay. Yeah, over there.
You said Ethereum and you said they. So who is they?
In case of Ethereum, okay, who is they for Ethereum? So Ethereum is run by Vitalik Buterin. That is the founder of the project, so he's definitely still involved. But at this stage, Ethereum is a whole community, and they have a whole process that they go about to change Ethereum and change their protocol. For example, anyone can go on GitHub and add a proposal to a change. They call it an EIP, I think. So basically, you could say, hey, I have a proposal. I want to change from proof of work to proof of stake. Then you write down your arguments. The community will vote on that. The community will weigh in on it and say, okay, yes, we want to do that. No, we don't want to do that. So that is who they are. It's the entire community of developers behind Ethereum. Yes, Bitcoin also has these improvement proposal type thing. What's also interesting to note is that these cryptocurrency projects are often open source, especially the bigger ones. So Bitcoin, for example, if you have an idea for an improvement, you go to GitHub, you download the code, you make some changes, and then you send it off and you say, hey, here's my proposal on doing things. And if enough of the community accepts it, then your proposal becomes a part of Bitcoin. And if there is a lot of debate about that, then you could get a hard fork, is what we call it. So for example, in the case of Bitcoin, there was this debate about how can we fit more transactions into a block. A block on Bitcoin is only 1 megabyte in size. And some people said, well, we're going to store them more efficiently so we can pack more of them into 1 megabyte, into that container, into that block. And other people said, well, we should make blocks bigger. Just make them 8 megabytes, for example. And these groups didn't agree. They couldn't reconciliate, they couldn't agree. So what they ended up doing is they went their own direction. So one group continued working on Bitcoin, the other one created Bitcoin Cash. Yeah. Yes?
So the value of the Bitcoin is created by the mining effort.
Yeah.
How does proof of stake then create value? Because you have to have had minimum of coins first. So do you have to have proof of work first to be able to get the proof of stake?
No, you don't. No. You can start out with proof of stake from the beginning.
What's the value of the coin?
Well, value is something really interesting because value is really determined by how much someone else is willing to pay for your Bitcoin or your Ethereum. So it's often said that the mining process is what creates the value, and the fact that you burn electricity, that creates the value. But that's actually not the case. It's actually the market that determines the value of your coin or your token. So for example, there's more ways in which you can influence the value. For example, Bitcoin, they have a fixed amount of Bitcoin that will ever be in existence, and the amount of new Bitcoin that is introduced in the system is actually halved every couple of years. So that also boosts the value because it becomes more scarce. So it's basically just the market that determines the value of your token based on these factors, based on how many are there, how much interest is there, what are people willing to pay for it, and so forth. Yeah. Yeah, in the back.
Great presentation, thank you. What do you think happens to the current cryptocurrencies if our government issues their own digital currency?
So this is something that I didn't address, it's regulation. There's very few regulations about cryptocurrencies, and that's a very big downside. But gee, I don't know what would happen if a government does that. I know that in Europe, for example, they're looking to create a digital euro, a blockchain-based version of the euro. I think governments are not known to be very good innovators. So I believe there will always be projects, like for example Ethereum, that take it one step further and will experiment with these new technologies. So I think that there is still room for independent, sort of say, cryptocurrencies. Yeah. Yes.
So one of the downfalls you didn't mention was that all cryptocurrency is really considered a security, and it really plays a part in the United States when you are getting involved with it. But you have to look at it as a asset, like a house or a car. So it's not like the dollar where a dollar is worth a dollar. In crypto, an asset when traded is a tactical event back and forth. So you constantly have to know what the value of each of the currencies that you're investing in is when you're trading other cryptocurrencies. Now it's a more complex discussion, but I think it's important to note that, one Bitcoin doesn't equal one Bitcoin. If you're buying Ethereum, you have to know what the cost of Ethereum is and the cost of Bitcoin to understand what your gain or loss is when you make that trade.
Yeah.
Because you're essentially trading stocks. I don't want to use the word stocks, but they're securities that you're trading.
Yeah. Yeah. Indeed. So was there a question as well? Or?
The question is, do you think that we'll get to a commodity market instead of a security market? That's my question.
I don't know. I don't know. I'm here. Yeah, I admit. I don't know if we will ever get there. A lot will depend on what regulators do, I think. I think right now, especially with what happened with FTX, for example, last week, there is a lot of fear that governments will come down on cryptocurrencies very hard and they will make it outright impossible to buy them or to own them, and that will crash their value. So, yeah, I cannot make a prediction of what the future will look like in that case.
Thank you for this. I mean, you did an excellent job explaining the basics, and I loved it. I'm sorry for that question. I was just curious your perspective on, if we're going to get to a point where mass adoption could be, easier for people to get into, because right now, as you explained, it is.
Yeah. Yeah. I think we will definitely get there. There's a lot of bright people working in the cryptocurrency space. There's just a lot of issues that we need to work through. Like, as soon as these things are scalable and they're easy to use and there is a regulatory framework, then I think, we'd be on our way for a lot more people to start using this in their day-to-day lives. But at the moment, I don't think we're there at all. Yeah. Yeah. At the back? Yeah, this.
Is it possible that we can even get out of cryptocurrency and go to crypto lottery so that someone's Picasso is worth someone's house directly? That's something that can ever happen.
Can you repeat the first part of your question?
Instead of a cryptocurrency, could it be replaced by a crypto lottery so that, as I said, someone would sell their Picasso for someone else's house instead of a coin being the intermediary?
Yes, I think you're more referring to like NFTs, really, where you're not representing coins, you're representing assets on top of a blockchain. So I think that is definitely possible. In fact, in my DeFi application, I do give the example of NFTs, where you can do stuff like this, where you can trade physical goods on a blockchain, or at least a representation of a physical good. Then you can say, I represent my piece of art as an NFT, I represent my house as an NFT, and then we can trade those on a blockchain, and they could exchange hands that way. Yeah.
How can we get a copy of your presentation?
Well, if you really want it, I think I can send it to the organizers, and they can make it available. But I'm not sure how useful it will be, because it's mostly icons and animations floating around the screen. So I designed these things on purpose. I designed it so that you have to listen to me and not read on the screen. So, but if you want it, I can definitely send it. And there is a version of this presentation actually that exists in multiple videos on my channel. So I have a video about blockchain. I have a video about Bitcoin hard forks. I have a video about hardware wallets. Cryptocurrency wallets. So, yeah, you could learn about it that way as well. Yeah. Yes. Yeah. Yes. So yeah, if that wasn't clear, obviously this presentation is highly simplified, but a block contains multiple transactions. So in the case of Bitcoin, you have about 1 megabyte of space inside of each block to store transactions into. So that is. Yes. So the mining process in the case of proof of work is basically you take the data that's inside of the block, you hash it, you get a certain hash. And the idea is that the hash should start with a certain number of zeros. And the output of a hash function cannot be predicted. So the only way to get a hash with a certain number of zeros is just to try a lot of combinations. So what each block will also have is a random number, a nonce we call it. And so what you do as a miner is you're just trying to set the nonce to random values until the hash of your block starts with enough zeros. And if that's the case, then you have a valid block and you get the block reward and so forth. Yeah. In Bitcoin, the mining reward will stop altogether. Yeah, it will stop altogether. Yeah, in a system like Ethereum's proof of stake, for example, they actually charge a fee for each transaction, and the fee is then given to the validator in that case. Yeah, but in Bitcoin, it will just fall away. Yeah. Other questions?
I'm sure Xavier will be around for questions afterwards.
Absolutely.